Okay, so in the previous video, we have learned why we wanted to estimate F. And that is if we want to predict a certain output from given features, or if we just want to understand the relationship between our features and the output. Okay, now I want to estimate F. We are now going to answer the how. Okay, but before that, this is the flow or the general flow of developing a learning algorithm. So we have the data, okay, we have the training data and the unseen data, but it all begins with the training data. Okay, we will use this data to teach the machine learning algorithm of the patterns. Okay, and after which we will have the model after training. And we will be using that model to predict or infer from the unseen data or the validation data, which termed in other textbooks. Okay, and that prediction or the inference will be evaluated. Is it accurate enough? Or does it infer enough? Or does it explain enough? Or does it give us the information that we want? So we are going to evaluate. So if the performance of that model is good enough, then we can deploy the model. Otherwise, we will continue training. Now, the question is, how do we train the machine learning algorithm given the data? Okay, so we will try to answer that. Okay, so now how do we estimate F exactly? Okay, let's have an example. We have here a diabetes data set wherein it is composed of some features like glucose, blood pressure, insulin, BMI, and age. And using these features or indicators, we can predict a person's probability of having diabetes or not. Okay, so we have a set of observations wherein each row can be considered as one observation. So denoted by I. And each observation I has associated the features like glucose, blood pressure, insulin, BMI, and age. So each of these features may be represented using notations x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5, while the outcome or the label is represented by y. Okay, so let x sub ij represent the value of the jth predictor or input for the observation I, where I is equal to 1 to n and j is equal to 1 to p. Correspondingly, let y sub I represent the response variable for the ith observation. So what it means is, suppose we have this one row. So this is our observation 1 or row 1. And we have predictors x sub 1 to x sub 5, or in this case, we have x sub 1 to x sub p. Okay, so and then the I refers to the number of observations. So from observation 1 until the nth observation. Okay, while the y sub I represent the response variable. Okay, so for this observation 1, this we use this notation xij. So this first cell, this may be represented by x sub 1 and 1, wherein the 1 refers to the observation 1 and the second one is referring to the first indicator or feature, which is the glucose. Then, okay, so the blood pressure for observation 1, may be represented with x sub 1, 2. The insulin may be represented by x sub 1, 3, BMI, x sub 1, 4, etc. While its outcome may be represented by y sub 1, or the outcome for observation 1. Now, we can divide our data into training data and the testing data. And the training data will then be consisted of the following. We have this observation 1, so which may be represented by these notations x sub 1, 1 until x sub 1p, as well as y sub 1 until this. So we have this, we are simply representing this, observations using this notation, okay? And using this training data, we will be applying a learning method such that we will be able to estimate the f, okay? So we want to find a function f hat such that y hat is approximately, may be approximated by the f hat of x for any observation xy.